Next topic, data types. So in previous class we discussed about different lexical conventions. So lexical conventions, there are many examples, operators, strings, and some examples we have to discuss in previous classes. So in next one, data types. So in all the programming, without data types we can't write a single line of programming. That is the what indicates importance of data types. So here there are so many data types with respect to Verilog HDL: value set, nets, registers, then vectors, integer, real, then time, then arrays, memories, parameters and strings. So these are all the belongs to what? Different data types with respect to a Verilog HDL. So first one we discuss about value set. So there are 4 value set with respect to what? Verilog HDL. So we just write the column here: value, level, condition, condition in hardware circuit. So there are 4 value set belongs to what? A Verilog HDL. The first value set is 0. So here 0 represent logic 0 as well as it's an false condition. It means when you applied the what? A value level, that is 0, and that time it should be a logic 0 with respect to a logic condition, and it should be what? A false condition. Usually there are 2 conditions we have to apply in Verilog HDL, either 0 or 1, either true condition or false condition. So in all the false condition we have to write a 0. That is the first one. Next one, 1. So here 1 represent, we named as logic 1. Then if it is 0 is false condition, obviously 1 is a true condition. For next one, so that is x, small x, so we call it as don't care. So don't care is very important because we are not applying any value with respect to what? Any register or any input or any output, and that time it takes a don't care. So don't care means either 0 or 1. So last one, I impedance. So here it represents a small z, the value should be what? I impedance. So usually I impedance is what? It's applicable only what? A input side. So these are all the what? A value set belongs to Verilog HDL. So I repeat again, 2 columns: value level, then condition in hardware circuit. So when you applied 0, it's a logic 0, then it's a false condition. When you applied 1, it's a logic 1, then it's true condition. When you applied x, then it's a don't care, either 0 or 1. So last one, it is z, then it is an I impedance. So these are all the what? Value set. Next we consider a strength level. So there are 8 strength level belongs to Verilog HDL. So first one, supply. So here supply 0 or supply 1, it depends on the what? Whatever input you have to apply. That is supply is belong to driving. Okay, so we have to drive the what? A supply signal. So that's why the type belongs to a driving here. So next one, strong. So here strong, it's another strength level. So here again it belongs to driving. So strong 0 or strong 1, again depends on the user. Next one, pull, again it belongs to a driving. So next one, large. So large, it belongs to storage. So here large, it may be some values, that's why we have to store, a type should be what? Storage. So next one, weak. So supply strong, then pull after a weak, again weak, you have to drive the what? Circuit to a weak, so that's why it belongs to a driving. Next one, medium, here once it is large, next should be what? Medium only, that's why it belongs to a storage. So next one, large, medium, then obviously it's small, then small is belongs to what? A storage one. So next, last one, that is IZ, we name it as I impedance. So here these are all the what? A strengths of Verilog HDL. So again I repeat, there are 8 strengths of Verilog HDL. Then here you represent first supply, that is we drive the what? Supply to a circuit, that's why we type is drive. Then strong, it's also a drive to what? A supplying, that's why it belongs to driving. Then pull, it also belongs to drive. Then large, as well as medium and small. So we have to store larger value, then smaller value, then medium value. So that's why it belongs to what? A storage one. So a large and medium and small, we have to store in the form of register, that is REG, we discussed later classes. So next, last one, I impedance, we simply name it as what? I impedance. So here the I impedance is we called as the degree is a weakest degree, then so it's further increasing, then after the supply is what? Highest degree. Why is supply is highest degree? Because of supply we have to represent in terms of voltage, so that's why supply belongs to highest degree. Then so I impedance belongs to a weakest degree. So here there are some condition with respect to what? This strength level. So what are the condition? Let us take one example here. So here you have to consider a 2 signal. Okay, you can consider any 2 signal. So let us take then strong one we have to consider. So next one I consider a weak one. So it may be a strong 1 or 0, it may be a weak 0. So here if it is strong 1 then weak 0. So which one is greater? Obviously strong one is what? Here strengthen here. So that's why when you apply the 2 signals, strong 1 and weak 0, then it produces strong 1. So that is the condition here. So next take another condition. So here take another 2 examples here. Suppose the 2 signals both are strong 1 as well as strong 0, then it produces a high impedance signal. Okay, so that is the what? A conditions here. When you applied both are different, that is strong and weak, then at that time it produces strongest signal. So that's why I mentioned strong 1. Suppose you have to apply then strong 1 and strong 0. So both are strong here. So then it produces high impedance. So these are all the what? Some condition with respect to strong level. So next topic, another data type, it's nets. Here in Verilog HDL net is a data type, one data type, physical connection between structural entities such as gates. So physical connection between structural entities means we have to interconnect a 2 gates. Okay, suppose interconnect 2 gates, and that time a connection between one gate to another gate we are using a nets. Okay, that is the a data type. Next, a net does not store a value except for try reg net. Okay, so it means here net is, it acts as a what? Only a physical connection. It acts as a connection between the two different gates. So here we can't store the what? A value here. So here for one condition, suppose we are using a try reg. Okay, it's the keyword, and that time we have to store the what? A value here using that try reg. Except this condition, we does not store any value with respect to net. So next move on to what? There are different kinds of nets. It belongs to a net data types. So many data types available, so many nets are available here. Okay, for example, wire. So obviously we are in Verilog HTL, we should use acts as a what? A wire. So there are another nets here. Try is the one net. We already discussed in previous point here. The try is what? We can store the value using try, then w or, then try or, then w and, then try reg, then try 1 and try 0. These are all the what? Examples. It belongs to a nets. So except this one wire. So in theoretically this subject we have to discuss wire in detail again. Okay, again we are using wire signal, okay, throughout the programming. But in practically in your lab we are using this type of signals, that is w or, try or, w and try reg and try 1 and try 0. Next, a wire net is typically used for nets driven by a single gate. So wire net is typically used for net driven by a single gate. Take one example here. This is the what? A gate symbol. So here the gate name it as what? GL. So here there are two inputs and one outputs. B and C is the what? Inputs of the that gate. Then A is the output. So what is the wire here? Okay, so A is the what? Wire. Because A is connected to what? We can possible to connect to another gate. So that's why here A name it as a wire here. So we can possible to connect another gate using this intermediate signal wire. So here B and C, when you changes the what? Value of B and C, and that time A should be what? Changes. So that is the what? A wire. So again we take examples for wire. The syntax wire is wire A. Okay, we represent the keyword wire. It's a net, that is the keyword wire A. Suppose we take one more example, wire 1 down to 0 A. So here wire 1 down to 0 A means here A is what? It's a multiple bit. Okay, we can represent A is the what? A multiple bit. I repeat, the what do you mean by net? So here net is a special data type, that is it acts as a physical connection between the two digital circuits. So next, net does not store any value, but one condition, that is when using try reg, and that time we are using what? A store, it acts as a storage device. So there are different kinds of nets available here. Then example wire, we are mainly used wire as a keyword for net. Then it may be try, that is tri, then w or, then try or, w and. So that r and indicates a name of the gate. Then it may be a try 1 or try 0 or try reg. So we already discussed try reg acts as a what? Here storage element. So here a wire net is typically used for net driven by a single gate. Let us take example here. The name of the gate is what? A GL. Then B and C is the inputs. Then A is the output. Here A it acts as a what? Output here, and also acts as a net because A is connected to what? Another one. So here example, write a syntax here for that is wire A is the one syntax. Suppose it's more than one bit, that time wire 1 down to 0 A. Okay. Next data type is registers. So in previous there is a disadvantage. The disadvantage is we can't store the value with respect to net except one condition, that is try reg, right? So that is the problem we have faced with respect to net. So here the registers, a register is a data storage element. Using the register we have to store the what? A data in the form of 1 or 0, 1 and 0. The keyword of register is reg, that is we represent reg, it acts as a what? A keyword of this data type register. So register store value from one assignment to the next. So it indicates we have to apply the what some values here. Okay, the output value or input value, it should be retained until the value is changes. That is the what a register specialty. So it's specially suited for a sequential circuits. So in sequential circuit, until the next value, the present value is what retained. Okay, so that is the example for a register we are used in sequential circuit. So the default initialization, that is the default initialization of value of a register is X. So when you applied any value, the default value should be what? X. So here X is don't care, either 0 or 1, or X is also called as unknown. So register can be used as a signed values, okay, signed variables. Be careful. So here we can't apply the what a unsigned variable. Okay, it should be what a signed variables here. Okay, that is the specialty of registers. Again I repeat, a register is a data storage element. It acts as a storage element. Then the keyword of the register is reg. Then register stores the value from one assignment to the next. So it means it should be what retain the value. Okay, retain the value until the value is changes. That is the specialty of register. Then the default initialization of register is X. Okay, we called as don't care, also we called as a unknown here. So register can be used as a signed variable. So let us take example or syntax for a register is register signed. Okay, be careful. Here we are not, we are simply indicates the what a symbol here, that is register signed, then MSB to LSP. Okay, this is the example for syntax for what a registers. So let us take example with respect to what a register. So let us, so reg reset, that is register reset. So here reset, it acts as a either input or output or any value, either input or in out. Okay, but here reset, it acts as a storage element, reg reset. So after you mention the what storage element, you have to initialize the data. That is in Verilog HDL we have to write initial, then we are using a keyword begin. We have to discuss in detail about initial and begin later classes. Initial begin, then register is equal to, sorry, reset is equal to 1 bit 1. So it indicates reset, the value of reset is 1, what, that is initial condition. Initially the reset value is 1. Then if you want reset the again the value, then you have to mention some delay. So here hash 100, it indicates a delay here. Again we have to discuss about this delay in later classes. As 100, then reset, then 1 bit 0. Okay, then end. So it indicates after 100 nanoseconds the value of reset should be what? 0. So why we take this example for particularly register? Because here you have to observe here the initial condition of the reset is equal to 1. Okay, then till the reset should be 1 up to what? 100 nanoseconds. Okay, after 100 nanoseconds you have to change the what? A reset value. So up to 100 nanoseconds the value is stored in reset. So that's why it acts as a what? A register here. Then after 100 nanoseconds the value becomes an what? 0. So 0 is permanently stored here. We are not mentioned after 100 nanoseconds here. 100 nanoseconds, so some infinite, the value of reset should be what? 0. Then end the what? Program. Next data type, vectors. So in previous data type, that is we have to discuss a net and register. So net is what? A physical connection between a different gates. So register acts as a storage element. But there is a problem with respect to what? A net and a register. So what is the problem? A net register declaration without a range. So we can't specify what? A range here. Okay, using that net and register. So specification is 1 bit wide. So if it is not specify any range, then obviously it's 1 bit only. So that is, we call it as a scalar. Multiple bit net and register data types are declared by specifying a range. We name it as a word vectors. Again I repeat, a multiple bit, that is more than one bit data types are declared by specifying a range we called as vectors. It means if you want more than one bit, and that time we have to what? Using this vector type. Let us write a syntax for this vector. So here syntax is MSP colon LSB. So here MSP in the sense the larger value. Okay, LSB means it's a smaller one. So sometimes the LSB is larger than MSP, but depends on the what? The condition of the program. Clear? So some MSB is what? Obviously it's greater than LSB, but sometimes it should be what? LSB is greater than MSP, but depends on the what? The programming one. So that is the syntax for a vectors. Let us take example for a vector. Example, here we take wire A. So here wire A is what? It's a single bit. Okay, that is scalar. So it indicates a one bit here. If you want more than one bit, and that time you write wire, the syntax is what? Square bracket, then 3 down to 0, we name it as down to, so A colon. So it's what? It's an 4-bit value. So here wire, it's a keyword, then 3 is MSB and 0. So it indicates it's an 4-bit A. So here A is what? A 4-bit. So let us take one more example with respect to a register, that is REG four down to 0 B. So it indicates here register acts as a what? A 4 down to 0, in the sense it's an 5-bit registers. Okay, these are all the some examples with respect to vectors. Advantage of vector with respect to previous data types: in previous data types we have to mention only a 1 bit. We can't mention more than 1 bit. At a time we are using this vector, so we can possible to what? Specify more than 1 bit at a time. Okay, next integer. So here it's similar to what? A C programming. Integer. So integer is a general purpose data type. In Verilog HDL it's used for manipulating the signals. So manipulating the variables here. So a register. So in register we can't store what? A negative number. Okay, we can't store a negative number with respect to a register, and that time the register can be replaced by the word integer. So here integer, using this integer we can possible to store the what? A negative value. The size of the integer, it should be what? A 32-bit. That is the maximum size of the integer. With that size we have to mention the what? A value here. So let us write the syntax here. Syntax integer underscore declaration, that is the declaration of integer. Then this is the what? We have to write the syntax integer, then list of the variables. This is the syntax for a integer. Let us take example for integer. Integer count, but we are not mentioned count value. So we simply wrote integer count, then initial count is equal to -1. So it indicates we can possible to mention a negative value. Let us suppose in terms of register count, you have to mention here initial, and that time counter is equal to -1. That is the wrong syntax. Okay, why? Because we can't mention a negative value with respect to what? A register. Okay, so usually for you have to mention the negative value, and that time there is no other possibility to use a integer. So that's why here we have to use integer count initial, then counter is equal to 1. Sorry, here count is equal to 1 -1.